Hello, my Algebra 2 friends. We are back with a lesson on solving systems of linear equations. This is going to be a little bit of a review from Algebra 1. We're only going to be solving systems that have two linear equations right here on this lesson. And as you progress through your math, you're going to see other types of systems that you might solve. We're going to use all three methods on this lesson: graphing, substitution, and elimination. First, let's talk about graphing. So when we graph a line, just a quick refresher, we love when they're in slope-intercept form. So y equals mx plus b. And the idea is the coefficient to the x, once it's in this form, this m is called slope. And remember, slope is rise over run. And then b, which is known as the y-intercept, is a great place to start your graph, because a y-intercept would be where your x value is a 0, so you can pinpoint that from the equation pretty quick and graph it along the y-axis to have a starting point. So for our equation, we have two of them. I'm going to start by graphing this line, 1/2 x minus 2. That line starts at a y-intercept of -2, so drawing a point on the y-axis at -2, and then your slope is rise over run 1 over 2. So remember, positive is moving upwards and right. A negative movement would be towards the left. Down is also a negative movement, but you gotta be careful about fractions because two negatives make a positive and all that good stuff. So let's remind ourselves how to graph lines. From our y-intercept, we're gonna move up 1 and then right 2 because your slope is 1 over 2. Now I have a really handy tool here that creates lines. I think this is what I use. Actually, I think it's a shape pen. I don't know. It doesn't really matter. Hey, it fixed it. That was nice. Alright, so then I'm going to graph the other line, which is -2x plus 3. So that line starts at a y-intercept of 3. Be careful on this guy's slope, though, guys. It's a -2 over +1. So if you're going to travel -2, that means you're going to travel down 2 and then +1 to the right. Again, I'm gonna, I can't draw by now, guys. I don't think this is a mystery. Here's the fun part. Because I can't draw, sometimes they don't work out so well, but the point in which they intersect, that is the solution to my system. So we're gonna write this as an ordered pair. Remember, XY ordered pair notation is how far to the right or left it is, and then how far either up or down it is from the origin. So this is the ordered pair 2, -1. You might want to write down a little note to yourself, just because it gets confusing when you're graphing lines and then writing XY ordered pairs. X is the 2 and -1 is the Y. Lovely. Now these lines, if I go to just graph them, they're already in slope-intercept form. This first one I would start at +2 as a y-intercept, and then his slope is a 2 over 1. So that means I would travel up 2 and right 1, and I'm going to kind of fall off the grid here. You could also move down 2 and left 1, because a negative divided by another negative would come out to a positive ratio. All these things we need to remember from back in the day, huh? Yeah, that didn't work. Okay, pretend that was drawn well. This next line is 2x plus 4. So this one starts at 4. Normally I'd travel up to right 1, but I'm going to fall off, so I'll go down to left 1. And you'll probably notice something kind of unusual happening. If I were to draw properly, which I did not, oh no. Alright, so this guy got a little weird, right? That's not better. There we go. These lines are not going to cross. They're not going to intersect because they are parallel. Now, I should have noticed they were parallel right from the get-go. If you have the same slope but different y-intercepts, that means you have two lines that are parallel to each other. They're never going to intersect. And as far as solutions, that means we have no solution. Please write out the phrase no solution. Don't put 0 with a line through it. Just don't be lazy. Write no solution. And if you notice without graphing it that they're parallel, that's great. You can just write parallel lines, no solution. Okay, be careful on this next one. Two reasons to be careful. First of all, this equation right here, this is not in the form that I like. This is called standard form, and I really don't like graphing unless it's in slope-intercept form. So I'm going to take this equation, and I'm going to rewrite it by solving for y. Remember all that work we did solving for y? So I'm going to start by subtracting the x over. I could have added the y, but whatever. So you got negative y equals negative x plus 3. And then I'm going to divide or multiply everything by a negative 1 to get rid of that negative in front of the y. So this equation becomes y equals positive x minus 3. Also, what I'll be graphing is this very unusual line of x equals 1. All right, let's graph the blue one first. Now that it's in slope-intercept form, I can see the y-intercept is going to be at negative 3. And then the slope that's in front of this x here, this is like a 1 over 1. So traveling up 1, right 1, up 1, right 1. And because I can't graph, this is how I like to graph them, by just drawing like a gazillion ordered pairs following that slope pattern. But it sure does help when you have a handy little shape tool here. Sometimes. Still can't graph. Ay, ay, ay. Good enough. Okay. So this line, x equals 1, this is the x-axis right here, right? So if I go to x equals 1, which is this point, and I want to create a line, it just means it's the line that goes through that point, and the x value is always equal to a 1. So we're looking at this. Yeah. So now I say, well, where did it intersect? I should be able to pull out this intersection ordered pair right here. This is located at 1, negative 2. So there's your solution by graphing. Graphing is not fun for me because I can't graph. So if given a choice, I really don't ever graph. That sounds bad. I'm a math teacher. But you know what I do is graph on the calculator a lot because the calculator's pretty. All right, so this equation, I'm going to do a little work over yonder. I'm going to get it solved for y. And I'm going to do similar work for this guy. I'm going to do my work over here and solve for y as well. So the blue one's going to take 2 steps. I'm going to start with, I should have drawn my arrow more over, x plus 2y equals 4. And I'm going to subtract x from both sides. Oh, this one's going to be icky. All right, so we got 2y equals, I'm going to rewrite the order as negative x plus 4. I want the x to be first. And then one more step and we're home free. I'm going to divide everybody by a 2. So we just got y equals, careful on this one, this is a negative 1/2 x plus 2. Ugh. And then this green one, much easier to get y by itself. I'm just going to subtract the 3x over. So it becomes y equals negative 3x minus 3. Sorry, my work got scrunchy there. Okay, the blue one, y-intercept form, now I see it starts at a 2. And then careful, your slope is a negative 1 over positive 2. So you're going to travel down 1, right 2. Down 1, right 2. Could also go up 1, left 2. That would still be negative. And then I'm going to ruin it by trying to graph a line. They're not getting better. They should be getting better, Abruzzo. Come on. Okay, the green one starts, I can now see the y-intercept is at a negative 3. Now your slope is negative 3 over 1. I would normally travel down 3, right 1, but I'm going to run off the page here. So instead, I'm going to go up 3, left 1, up 3, left 1. And even with my really crappy graphing, I saw right there where they intersected, but, you know, to be thorough, oh gosh. Okay, so I was about to say I was going to draw a line. I didn't draw a line. I don't know what that was. Okay, there we go. Now I can see the intersection point right here. And it is clearly negative 2, positive 3. Ugh, all right. So that's just one method. That's graphing, and I can't think of a person I've ever met in my whole life where they're like, yes, please let me graph to find the solution. Nobody likes graphing. Substitution is a distant second from everyone's first choice, but sometimes it determines, your choice is determined on what the problem looks like. Some of them are set up for substitution, and we'll see in the next method, some of them are set up for elimination. Substitution is actually my personal favorite, even though no one agrees with me. So the idea is if you could solve for y or for x in one of the equations, you can substitute that expression into the other equation. So for instance, right here, it says y is 5x plus 23. which means anywhere else in the problem, if you have a y, you could replace it or substitute in a 5x plus 23. Like right there, guys. So instead of saying y equals, we're going to say 5x plus 23 equals negative 7x minus 13. And then we just have a nice equation to solve. So I'm going to put my equation, oopsies. I don't want to forget all my good skills on solving equations. Let's solve this baby. Most of you would bring the x's over to the left, which means you'd bring the constants to the right. Most common mistakes here are basic arithmetic mistakes. Have that calculator handy when you're testing. I don't want you getting this wrong because you can't add. This is usually where I screw up because I can't add. Like literally. Alright, negative 36. So 12x equals negative 36. One more step and we're home free. Kind of. We're going to divide both sides by 12. And we're going to get x equals negative 3. Now, that's only half the story. All you found for me right now is that x equals negative 3. But I still need to know what y is. Well, you got a recipe for y up here. This thing you boxed in, it tells you exactly how to find y. It says y is 5 times x plus 23. Well, y'all, we just found x. It was negative 3. So, super mental math. Here we go. Negative 15 plus 23 is totally an 8. So it turns out y is an 8. That's substitution. Okay, so taking one equation piece, plugging it into the other one for that variable. It only works when you can actually solve for one of the variables first. So like number 6 is a great candidate for substitution because it already has it solved for y. It says y equals this. So that means anytime else you see a y, like for instance right there, you can substitute that in for y. So this problem, I wrote way too big on this question. Let me back up and erase this. Negative 3, 8, negative 3, 8. Don't forget the answer was negative 3, 8. I guess it is over here. But. Okay, so this bottom equation, I'm going to keep the 6x. I'm going to keep the plus 3, but instead of times y, I'm going to replace what y is. Y is now a negative 2x plus 1. So what you're doing, this is a nice math trick called substitution. Instead of having two variables working in your equation, now you only have one kind of variable. You got to solve like always, but we do have quite a bit of simplification to do here, guys. So I think a line would help me out. I think anything would help me out at this point. All right, this becomes 6x. Oh, that's not helpful. Okay. Got line segments going on. Let's delete that. Delete. Okay, so you all probably have it solved. The answer is, the next line is 6x, and then careful here, this is now a negative 6x. That's weird. And then a plus 3. And the rest of the equation says equals negative 5 still. Something very weird is about to happen. The 6x and the negative 6x, when we smush those together, they end up canceling each other. And now you have the very strange equation that says 3 equals negative 5. So when your x's cancel out, you have what's called a special case. You either have a case where it's all solutions, meaning everything works, or no solution, meaning nothing works. There's no solution. Guys, 3 does not equal negative 5. That's not true. So this is a case for no solution. Because of that very reason, 3 does not equal negative 5. If we were to graph these lines, you would see they were parallel. And now that I look at the line a little closer, I'm like, yeah, they were parallel if I solved that bottom one. But you got to do the right method, and that's what annoys kids. If I say solve this with substitution, you have to solve this with substitution. So number 7, we're going to solve this with substitution. Bummer. Nobody is solved for. It doesn't say like x equals or y equals anywhere. So the good news is you can solve for anything you want. You want to make your life really easy. So try to find a variable that is all boring. So it has a positive 1 coefficient. I'm thinking this guy right here would be really easy to isolate. I could just add the y over to the other side, and this becomes x equals y plus 1. So that's the same thing as this equation, but we're not going to use this version of the equation anymore. We're going to use the rearranged version. Now this time we're substituting in for x, so go up to the other line, and instead of an x, we're going to replace it with that. So we have a -2, and then not an x anymore, we got a y plus 1 plus 2y equals -2. And here we go, we're going to solve. So this becomes, let's see, -2y minus 2. We still have this plus 2y right here. And once again, we have what's called a special case, or an unusual case. Yeah. When I go to simplify this, and I join up my -2y and my 2y, these end up canceling each other out. Now this is not no solution this time, because look at what we have. We have a -2 equals a -2. That is 1000% true. That's not even a math thing. But that is true. -2 does equal -2. But it's not what we call a unique solution. So what would happen here is if we graph this, they ended up being the exact same line, and they cross everywhere. So no matter what I plugged in for x, or no matter what I plugged in for y, I would always get a solution, because they're always crossing, because they're the same line. So what we're going to say is infinitely, and you can abbreviate infinitely, many solutions. That's an L, that's an S. Okay, I'd love you to write infinitely many solutions. If you wrote many solutions, I get what you get. All right, if you wrote the infinity symbol, that's wrong. Don't write the infinity symbol. That means something totally different. We're going to learn with domain and range. Actually, we already learned it. Never mind. So infinitely many solutions, or you can say many solutions. Oh, no. So bummer, none of these have a boring coefficient of 1. So now I think, who would be the easiest guy to solve for where I wouldn't create any fractions? And I got my eye on this y right here. I think that y would be really easy to isolate, and it wouldn't give me any fractions because I'm going to divide everything here by a 3. So, do a little work here with me. I'm going to start by adding the 6x over. So it says 3y equals 6x minus 9. And then divide everybody by 3. Alright, so this blue equation, I'm going to call it, is now y equals 2x minus 3. So this is where the substitution comes in. I have a better way to say y. It's 2x minus 3. And I'm going to substitute him in for the other y in the problem. So forget that. This now says 7x minus 5 times my y, which is 2x minus 3, equals 21. It's solving time, kiddos. Oh boy. I think I'm getting old. Like mid-problem, I forget what I'm doing. Alright, we are going to have to clean this side up quite a bit. We have a -5 to distribute. So we still have a 7x, but this becomes a minus 10x. And then a plus 15. It still equals 21. Some like terms over here, smush these together. That's a -3x plus 15 equals 21. We're going to subtract 15. I think I'm losing my voice. Oh no. Alright, so what do we have here? -3x equals 6. One more step and we got x. So this was not like my favorite question. And we just found out that x equals -2. We're not even done. Alright, so the ordered pair, x equals -2. Cool, cool. Remember, you have a recipe for y right here. All you have to do is take 2 times x minus 3. So 2 times x, which is we just found to be -2, minus 3. Okay, mental math. -4 minus 3 is -7. Should write that down. And there's your ordered pair. Wow, I hope you can follow my work. That was like a little scavenger hunt. Okay. That was not nice, that question. I didn't like it. And if that question showed up on the SAT and it said solve, I definitely would not have picked substitution to solve this one. I would have picked what's called elimination. You guys love elimination. I don't know why kids love it so much, but you do. So the idea for elimination is if I were to just add the equations together, like vertically, like line up the x's and y's and constants, if I get an equation where one of the variables eliminates itself, then I'm ready to solve. So like right here, the x's are going to eliminate. They're going to cancel out. The fancy name for this, by the way, is linear combination. We'll talk about that in a minute. So if I were to add up these guys, these y's, you have a 2y, and then negative 5 plus 3 is negative 2. So now you got a little tiny equation to solve. Divide both sides by 2, and you find out that y equals negative 1. Now, the downside to elimination is there's no nice way to find the other variable. You just go up to the original equation and pick your favorite one. So I'm going to pick the favorite equation to be the top equation because it, I don't know, has less negatives. And careful, this is y equals negative 1. So we're going to plug that in right here for the y. So this becomes 9x plus 5 times negative 1 equals negative 5. And then we got to solve this. So simplifying a little bit, this is now a minus 5. Oh man, don't panic, guys. We're going to add 5 to both sides. And we're going to get 0. But that's okay. 0 is a number. 9x equals 0, and if you divide both sides by 9, you still get 0. So now, don't forget, I want your answers written in ordered pair notation, and your ordered pair has to go x comma y, so 0 comma negative 1. Lovely. That problem worked out really nicely because things were already set up to eliminate. This next one isn't so nice because nothing eliminates. But if this 10 was a negative 10, that would be beautiful. So what we're doing right now is we're creating what's called a linear combination of this second equation. We're just multiplying every single number in it by a factor, negative 1 this time. And we're creating a new equation. So we got, I'm going to write it under here, negative 10x minus 5y equals negative 15. So I'm not even looking at this equation anymore. And now when I add them together, some really cool things happen. These cancel, and the y's cancel. So you end up with 0 plus 0, and the constants cancel. Well, this is a true mathematical statement. 0 plus 0 does equal 0. So it's not no solution. This is a case for infinitely many solutions. And again, I like when you abbreviate because I can't spell infinitely either. Don't write the infinity symbol. That would be wrong. Oops, solutions. All right, so what do we do when nothing's ready to cancel and it's not an easy fix? Well, you got to look for what's called, you got to look for numbers that would be multiples of each other. So there's no wrong answer, and you just choose whether you want to eliminate the x's or y's. Logan, would you like to eliminate the x's or the y's?
X's.
X's. Nats, you okay with eliminating the x's?
Mm-hmm.
Okay. So when I look at my x's, man, if this guy right here was a positive 35x, that would knock out with this negative 35x. So what we're going to have to do to create that would be to multiply this equation by a negative 5. The negative is going to change the sign, and the 5 is going to change it to a 35. All right, I am going to just rewrite the whole system off to the side. Oops, wrong color. So we have a negative 35x plus 5y equals 21. And then this new equation, now that it's a linear combination of the original one, is a positive 35x minus 5y equals negative 25. When I go to add these up, something strange happens. This knocks out to 0, and this also knocks out to 0. But this time, this solution set does not. It equals negative 4. So friends, does 0 equal negative 4? Hey kids, does 0 equal negative 4?
I don't know. Yes.
What?
No. I don't know.
Those are weird.
I haven't heard a single thing when you were gone.
Yeah, you haven't been watching at all. All right, 0 does not equal negative 4, so that means there are no solutions to this problem. Kids. All right. Oh, no. Hey, Natalie, X's or Y's?
Why?
Ooh. I mean, that's okay. Can you change your answer? So the reason I want Natalie to change her answer, just to mess with her, the X's already have opposite signs. And I know my issue is I screw up signs all the time. So if I don't have to mess with negatives, I'd prefer that. So Nats, if you don't mind, I'm going to eliminate the X's. Now 6 and 7, their first multiple together is a 42. So that kind of is nice. We're going to multiply this guy by a 6. And we're going to multiply this guy by a 7. Hey, I'm teaching a math lesson over here. Be quiet. So this top equation becomes a negative 42x plus 18y. Oh no. All right, if I pretend that's a 20, that's 120. But then I got a minus 6 from that. So that's 114. You like that mental math, guys? That was good. All right, this red equation becomes a positive 42. Notice I didn't mess with the signs because they're already going to knock out because they're opposites. Oh no. Oh no. Okay, 28, 98. 14, I broke up into 10 and 4, and then I was like 70 plus 28. I've been doing a lot of little kid math this summer, so I'm getting good. All right, here we go. X's are gone. Oh no. 40, 50, 3, y equals, okay, if we pretend that's 100, but 2 less, so 212, that doesn't, is that right? Yeah, that is right. Okay. And then if we divide both sides by 53, that works because 50 and 3, that would be a 4 and a 4. So 4! All right, y equals 4. That was a big struggle, guys. That was like little kid math, and that was a struggle for me. Ooh, welcome to summer. All right, remember, this is not the end of the problem. You still have to find x. So you pick your favorite equation from earlier. I'm going to go with this red equation on bottom because it was more positive. And then I don't know what x is, but I do know that y is now a 4. Let's see here. Oops, I meant to make that a black one. So this is a 20, right? 6x plus 20 equals 14. And then if we subtract 20 from both sides, oopsies. All right, 6x equals negative 6. And I don't know if you've noticed this, guys, but all of our answers have come out really nice. Like no fraction and decimal answers. Sometimes a negative, sometimes a no solution. But that's what you can expect from Algebra 2. Your solution should come out really beautiful. Integers. If you get something weird in fraction-like, something's wrong. These are really easy to mess up on, so do go slow. That is all 3 methods of solving algebraic systems. And then our next lesson is going to talk about the word problems for how we set up word problems in these really cool applications. They're not that cool, I'm lying. All right, practice, 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 guys. You got to know all 3 methods and be able to do any method I ask on any particular problem, even if it's not the method you like best. All right, good luck.